Um, Good afternoon. Is this an okay sound, everybody? Okay, good. Well, thank you all for coming. We'll just go ahead and get started. My name is Steve Hammersmith. I'm with Shur Farms Frost Protection. And we will go ahead and get started. This presentation is going to be about cold air removal technology and managing the microclimates, which the microclimates basically are the differential in temperatures between in the areas in your vineyard. I'll have to do this. Let's see. Okay. We'll start off with the types of frost. I'll go through this fairly quickly, this part, because I think probably all of you know the different types of frost, or you should, but just in case you need a refresher. There's what's called advective frost, and what an advective frost is a cold winter storm. It usually comes in, well, this was made in the northern hemisphere, so in your case it probably comes in from the south. It's a winter storm. It's a regional frost event, meaning that it covers a wide area, and it's characterized by winds and clouds, hail, sleet, snow, all those wintertime phenomenon that you see in a cold winter storm. The temperature, it gets colder as the distance from the ground increases. Okay, so the higher up you go, the colder it gets. And the reason for this is an advective freeze is a cold air mass that comes in over the ground. And it could come in, it's arbitrary, it could come in at 100 meters over the ground, it could come in 50 meters over the ground, and at varying depths. It could be a depth of 100 meters or 500 meters. So if somebody's planted above, in that case, if somebody was planted at above 500 meters or below 100 meters, they would not be affected by this advective freeze. So that's why you would see people down lower that don't get frost damaged, or at least they have the normal frost patterns. And people up higher don't get frost damage. But typically speaking, the tops of your hills get damaged. Everywhere gets frost damage. There's nothing that's saved. It's not a normal type event. The next type of frost is a radiation frost, and this is what we'll be dealing with, and this is what your chronic frost is. And when I say your chronic frost, and what you have to deal with, advective freezes, like we just talked about, they don't happen very often. It's an out-of-region event. Just to go back, just to regress just a little bit on that, is those advective freezes typically are not any colder than what you normally experience weather-wise, but it happens either a little bit later than it should, and the vines are out, they're already budded out, or you've had an unseasonably warm spell during the wintertime and your vines come out too early. They'll come out 3, 4, 5 weeks early, and then you have a normal winter frost event, and you get nailed because your vines are not dormant. But typically speaking, it's not like those advective freezes are anything unnormal. That the temperatures are not radically different, radically colder than what you normally experience. It's just that it comes out later. It's just an inopportune time. Radiation frost can happen it happens everywhere. It's called a temperate climate problem. It happens everywhere you can grow. And what happens there is that a radiation frost is associated with an inversion layer, and it's the most common type of frost. It occurs only at night. This is a nocturnal event. It happens when there's clear skies and little or no wind and low dew points. And this is the way that works is it's called a radiation frost because the Earth cools itself. We get in heat every day from the sun via radiation, which is a shortwave radiation wave during the daytime, and then the ground releases heat into when there's clear skies and no wind through what's called the atmospheric window, which is a window of 8 to 14 microns in diameter. So any radiation that comes off of the ground that fits in this spectrum, which is an infrared scale, long wave radiation, will leave the Earth and go back into outer space. This is how the Earth cools itself. every day. And it has to be over, it doesn't have to be in the same spot where you have an equal amount of, of energy coming in and energy leaving, but overall it does have to be pretty much exactly equal throughout the entire Earth. If it's not, if there's even a slight variation between what comes in and what goes out, over a period of tens of thousands of years, we experience global warming or global cooling, and which obviously happens quite regularly, but it's a slow process, and that's how it happens. So when the ground loses heat under clear sky and no wind conditions, that's a normal thing. What happens then is that the ground, when the sun goes down at night, I'm going to vary it just a little bit from when the sun goes down on a frost night, typically those frost nights, you probably, if you've experienced this radiation frost, you probably already know those are the days preceding the night that they have a frost. They're nice days, they're sunny, they're clear, they're warm, and they have a very low dew point. And you can almost feel it that you're going to have a frost that night. But the ground absorbs heat during the day, and the ground gets warmer than the air. So when the sun goes down, hopefully, the world is right, the ground is warmer than the air. But when the sun goes down and we start this radiation process, the ground loses heat faster than the air does. And some types of soil lose heat faster than other types. Sandy soil, loose soil loses heat faster than a hard-packed soil or dark soil or wet soil does. But when the ground temperature gets below the air temperature, now you are at risk for a radiation frost. Until the ground temperature gets colder than the air, you're not at risk for radiation frost because you haven't started developing an inversion. What happens when the ground temperature gets below the air temperature is the air molecules touching the ground conduct their heat, which is heat transfer from molecule to molecule, conduct their heat into the ground, which then loses it to outer space through radiation waves. Radiation is how energy can travel through the atmosphere without losing itself. It's the only way. So now what happens is you have the lower layers of the atmosphere is colder than the upper. It's basically like, a good analogy is if you took a steel rod and you stuck it in a bucket of ice, the molecule in the steel rod right next to the ice will lose its heat into the ice. Then the one above that will lose its heat into that molecule and then conduct it into the ice, and then so on, all the way up. If you keep that steel rod in the ice bucket long enough, eventually the top of the steel rod is going to chill. When we talk about radiation frost nights, and that's the same exact process that happens, molecule to molecule, losing heat into the ground, which goes back out, we typically will experience only a maximum of about 100 meters from the ground where that chilling takes place. After that, there's not enough time and the sun comes up. So that's about the maximum effect that you're going to see. So what happens, you have two layers of the inversion. You have a lower inversion, which is typically up to about 100 meters from the ground. And then you have an upper inversion, which goes from about 100 meters to 300 meters. Above that, you have the normal advective cooling, which is your 2 or 3 degrees temperature loss for every 300 meters that you go up in height. So only the lower inversion, when the sun goes down all the way from about 300 meters to the ground, it's pretty much the same temperature. But the temperature changes from the first 100 meters on down more drastically along the ground, less drastically up at 100 meters. So you may lose 6 or 8 degrees Celsius along the ground and only half a degree at 90 meters. And then it varies between that, which is why you're warmer up here. You don't get warmer up higher during the night. You get colder along the ground because the ground is chilling the air. That cold air layer that's along the ground is heavier and denser than the warmer air layers up higher, and if there's any slope at all, that cold air will start along the ground. It's affected by gravity. It'll start moving downhill. That's called a katabatic wind or a downslope wind. When you have this inversion layer,
what I was saying is enjoy